Today we're going to look at section 4.9, quadratic inequalities. Our objectives are to be able to graph a quadratic inequality and to be able to graph a system of quadratic inequalities. In our first example, we're going to look at one in standard form. So if you remember when we did this, a couple of things we're going to notice is now we have a greater than symbol. Remember, a greater than is going to give us a dashed graph, and then we're going to have to use a test point to see what side we're going to shade. So this is our standard form, so the first thing I want to look for is my vertex. So I'm going to use opposite of b, okay, opposite of b over 2 times a to get the x value of -4. So I know my x value is at -4, and all I'm going to do is substitute that into my original equation and solve for y to figure out what my y value of my vertex is. Okay, -4 squared is 16 minus 32 plus 12. So 16 minus 32 is -16 plus 12 is a -4. So I'm going to graph -4, -4. That's my vertex. I know this actually faces up because my lead coefficient, my a value, is 1. Okay, now let's find some other information. Okay, I know my axis of symmetry, okay, just to kind of help me, is going to go right through here. You don't have to draw it in. It's x equals -4. But I do want to find my y-intercept. That'll help me. My y-intercept is when x is 0. If I substitute 0 in for x, I'm going to get a value of 12. Okay, so I know this is just a tiny bit off our graph, which is okay. So 0, 12, I don't have to worry about changing the scale too much. Now, if my axis of symmetry is here, if I have a point at 0, 12, I also have a point at -8, 12. Okay, so I'm going to just put a point up here. Okay, in this one, we're not going to worry. You could use quadratic formula to actually solve for the x-intercepts, but we just need a light sketch here. So what I'm going to do is now graph a parabola. Okay, but it's going to have a dotted line or a dashed line. Okay, remember this does go on forever. But now I got to decide which side of this I'm going to shade. Now, some of you might already know that we're going to shade this part just by looking at the equation when all the y's that are greater than this. But I can use the test point 0, 0. If I substitute in 0, 0 and see if I need to shade that, is 0 greater than, if I put in 0, 12? That is a false statement, so I know I'm not going to shade the side with 0, 0. I'm going to shade the quote-unquote side of the parabola that does not have 0, 0. Let's look at our second example. This one happens to be in vertex form. So I know it faces down because of the -2. And my vertex, I can just look at this and take the opposite of what's inside, because that's my h value is actually a -1, and then my k value is a -4. So I'm going to go -1, -4. Okay. Now I'm going to find, again, I'm going to choose to find the y-intercept just to make this a little bit easier, and that's a lot what we did in class. So we put a 0 in for the x. If I do that, I'm going to get -2. 0 plus 1 is 1. Quantity squared minus 4. You cannot multiply these first. You have to do order of operations. So exponent 1 squared is 1 times -2 is -2 minus 4 is -6. So I know at 0, -6, I get a y-intercept. Now please take note that this is down. A lot of students then mistake this for the vertex and then graph a parabola facing up. So make note that it's down. So I'm going to get a symmetric point at -2, -6. Now this one doesn't have any x-intercepts. Okay, so that tells me that when I solve this, I'm actually going to get 2 imaginary answers instead of 2 real solutions. So this is a downward facing. It is solid because this is a less than or equal to. Now you might just be able to tell that, well, if I have less than or equal to, I'm going to be shading below my graph. But let's try the test point. If I substitute in a 0 for y and a 0 for x, well, we know if we substituted a 0 for x, I got -6. Is 0 less than or equal to -6? No. So that's why I know I face on the other side. The nice thing about using 0, 0 as a test point is you can always tell what the right-hand side is going to be if you find the y-intercept because you already did the math. Okay, let's look at our third example. This one happens to be in intercept form. So again, I'm going to look at the symbol, and I know this is going to be dashed. The dashed ones are the ones students mess up the most because you guys are so used to drawing solid lines. So if it is dashed, give yourself some sort of notes. This one I know is going to face up as well because my a value is positive. Okay, so I'm going to find the first thing, the easiest things to find are my x-intercepts. So let's find the x-intercepts, and that's because it's an intercept form. This is when y is 0. So just to remind you of what we've been doing, so x is going to be what we're going to solve for. You guys just actually have done lots of problems like this. It's called our zero product property, when we had things multiplied together that equal 0. I don't have to worry about the 1/2 because there's no x here, but this means x minus 2 equals 0, or x minus 8 equals 0. So that's why I get x equals a positive 2, or x equals a positive 8 when y is 0. So I'm going to get 2, 0 and 8, 0 as my x-intercepts. So I'm going to go to 8, 0 and 2, 0. Well, to find the vertex, we should know that these points are symmetric. So that means that halfway in between, which happens to be right here at x equals 5, so if you need to draw a line to help you, please do that, is where my vertex is going to be. So I know my vertex is going to be at 5 comma something. So what I can do is substitute 5 into my equation. 5 minus 2, 5 minus 8. So I'm going to get 1/2 of 3 times a negative 3. So that's 1/2 of negative 9, or negative 4.5. So if I go to 5, and then down to negative 4.5, that's where my vertex is. Okay, and I know it's facing up. You could get a little bit more detailed, and you could find easily the y-intercepts. Remember, y-intercept is when x is 0. There's always just going to be 1. So if I put 0 in for x, I'm going to get 1/2 times negative 2 times negative 8. Well, that's half of 16, which is 8. So I could actually put in 0, 8, which also means I'm going to have one at 10, 8, just to give me a little bit more accurate graph. I know I'm going to draw a dashed parabola that goes through all 5 of these points that I have drawn. Okay, and now I need to decide what shading. I want all the y's that are less than this, so some of you might be able to just look and say, well, where's less than this parabola? Okay, it would be all of this area. And again, you only have to shade the part that's actually on the graph, even though it does go on forever. But we can do a test point. Let's substitute in 0 for x and y. We know that if we substitute 0 in for x, we get an 8. Is 0 less than 8? Yes, that is a true statement, which means whatever part has the 0, 0 is where we're going to shade, and I've shaded that part. Let's look at our last example. Now we're graphing a system, so I'm graphing 2 parabolas on the same graph, and then looking for where their shadings overlap. Okay? I have both here are actually in vertex form to make it a little bit easier. So the very first one, okay, I know is going to be a dashed parabola. I know it's going to face down because this is negative, and I know it has a vertex of positive 3, positive 8. Okay, I'm also going to find the y-intercept. The y-intercept, okay, is when x is 0. If I substitute 0 in for x, I'm going to get negative 1/3 times negative 3 squared plus 8. Well, negative 3 squared is 9. 9 times negative 1/3 is negative 3 plus 8 is 5. So I'm going to graph 3, 8. I'm going to graph a y-intercept of 0, 5, and I should see that this faces down, which means that at 6, 5, I'm going to have its symmetric point. Okay, you could go through and solve for x-intercepts. They don't come out very nice, but I'm just going to do a light sketch now. And you always want to graph all the way through your graph. Don't stop right here. So I'm going to keep going down. Okay, again, it's just a light sketch. I'm going to actually graph both and then kind of shade, but we can kind of talk about this one, where the y's are less than it. I'm actually going to be shading inside my parabola, okay, underneath it. So I'm going to switch colors just so we can see the other one. If we look at the second parabola, this is going to be a solid one. It's actually going to face up, and it's going to have a vertex of positive 3, negative 2. It's going to have a y-intercept at 0, comma. Now if I put 0 in for my x, I'm going to get negative 3 squared minus 2. Negative 3 squared is 9. 9 minus 2 is 7. So now I can graph at 3, negative 2, and then put a point at 0, 7, which tells me, again, this is facing up, that I'm going to have a symmetric point at 6, 7. So this is a solid parabola. Okay. And now I want to shade all of the y's that are below or less than this. I could use a test point of 0, 0 for both parabolas because either of them go through the point 0, 0. And if I put 0, 0 into each of these, I'm going to get is 0 less than 5, because I know that's the first one, and is 0 less than 7. In both cases, this is true. So I'm going to shade, the overlap for both of these is where 0, 0 is. So that's all of this area that's below the red, but also below the green. Okay. All of what we just did today is review. You've graphed all of these parabolas in all these different forms, and you have done actually graphing of inequalities before. But we're just kind of putting it together for our quadratic section.